This is question number 3 on practice homework 9 for chapter for module 13. Estimate. This is another question on the valuation of equity using the discounted cash flow model. So we just directly look at part A. So we're provided with sales, NOPAT, NOA numbers for a bunch of years. So the first part of the question asks us to assume the following forecasts for sales, NAPOT, and NOA for and forecast the terminal period values, assuming a 1% terminal period growth rate for all 3 model inputs. So this is like using the parsimonious model, right? Because all the 3 inputs grow at the same rate. We just need basically forecast these 3 numbers instead of all the financial statements. So first, let me copy the numbers into my spreadsheet and paste the special text. And so the terminal period, this is terminal period, and we're given that all these 3 inputs here will grow at 1%. So it's going to be 2019 number times 1 plus 1%. And we have to pay attention to the rounding requirement. Here it asks us to round your answers to the nearest dollar. So we need to use the round function and keep 0 decimal place. And we want to do the same. And also we want to change the format just to change to be general. Then it will just keep no decimal place. And we want to do the same, drag the cell to the other 2 variables, and this will give us the terminal period numbers values for all these 3 numbers. So then we can just copy the number back. And B, estimate the value of a share of TXRH common stock using the discounted cash flow model. So we assume that discount rate of 7% common share outstanding and the net non-operating obligations of, notice here is a negative number. But here it asks us to not use negative signs with any of your answers below. So when we input the NOO in the table here, we just put its absolute value. But when we do the calculation in Excel, we can put this as a negative number. Then we can subtract a negative number and it becomes adding a positive number. And we also know the non-controlling interest. And so we also need to deduct the non-controlling interest. Note that and so we also need to pay attention to the rounding instructions. Use rounded answers for subsequent computations. Round answers to the nearest whole number unless otherwise noted. Round discount factor to 5 decimal places and stock price per share to 2 decimal places. So in order to calculate the free cash flow to the firm, we first need to calculate increase in NOA, right? Increase in NOA. So we start from 2019 because that's the first year the difference can be calculated. So it's going to be 2016 number minus the 2015 number, and then we can drag the cell to the other years. And so then we can calculate FCFF. So FCFF basically is basically NOPAT minus the increase in NOA, right? So it's going to be NOPAT minus this number here. So then we can also drag the cell to the other years, including the terminal period. So then the next input is the discount factor, right? Discount factor. So to get that, let me first discount factor. Yeah. So this is basically equals 1 over 1 plus the discount rate. So discount rate is the WACC, which is 7%. It's provided here, so it's going to be 7%. But then the power, even though here, actually for the first year, I don't need the power, but in order to track the sale to the other years, I can put the power, which is the year number 2016 minus the starting year number, which is 2015. So the reason I got 1 is because for match sales, and if I remember correctly, it asked us to keep 5 decimal places. So I just follow that, and then I can actually it's better just also to use the round function to do that. So it's going to be 5, and then I can drag the cell to the last horizon period 2019, and then I can sum up, right? I can sum up the actually I can the present value of horizon FCFF, right? So that this is gonna be just multiply the FCFF by the discount factor, right? So then I need to follow the rounding requirement, round to 0 decimal place. So do that for all these years. So then I can calculate the cumulative of present value horizon FCFF, right? So that's gonna be the sum of these 4 numbers, right? So again, yes, that's gonna be and then present value of terminal FCFF, right? So this part is requires us to be very, very careful. So we're gonna be using the FCFF of the terminal period and then divided by the discount rate, right, 7%, and then minus the growth rate of the terminal period, which is 1%. But remember, so far, the present value we calculated is based on 2019. So we still need to discount it by 4 years back, right, to 2015, the true current. So that's going to be 1 plus the 7%, and then raised to the power of 4, right? So this is going to be our present value of that. So again, we need to use the round function to round to 0 decimal place. So then the firm value, right? Firm value is going to be the sum of these two, right? Sum of these two. So then we need to deduct NNO and NCI, right? NNO is, as we mentioned, this turns out to be a negative number, so we just put this as negative. This is negative. And NCI is a positive number, so this is 7. We just copy this number here, right? So, and then equity value. Equity value is simply the difference between the firm value and the NNO. NNO here is negative, so we will end up with adding a positive number and then minus NCI. So then shares outstanding. This is simply the, if I assume this is this number, common shares is this number. And then price per share. So this is going to be just a, we divide equity share by the total shares outstanding. So then we just need to follow the rounding requirement, round this to 2 decimal place, right? So 44.21. So the rest of the job is simply to copy all these numbers back to the table as required. All right, so part C is the price actually closed at $42.13. So our estimated price is slightly higher than the actual price on that day. So So how does your valuation estimate compare with this closing price? Obviously, this is a little bit higher. So we just need to, so this first one, stock prices are a function of many factors. It is impossible to speculate on the reason for the difference. And that cannot be the right answer. It can, even though there are many factors which determine the stock price, but based on the estimate, we can still say something about the underlying factors. Our stock price estimate is higher than the market price, indicating that we believe that the stock is slightly undervalued. And that's true. Stock prices are a function of expected NOPAT and NOA as well as the WACC discount rate. Our higher stock price estimate might be due to more optimistic forecast or a lower discount rate compared with other investors and analyst model assumption. This is correct, right? Because the lower the discount rate, the higher the estimated price, estimated value. And our forecast for example, the growth rate for the terminal period might also be more optimistic. So that can also drive up the intrinsic value. So this is correct. We don't even have to look at other answers. You can, I believe, if you do that, you will find out they are not correct. So part D, if WACC had been 7.5%, so currently WACC is 7%. 7.5% is slightly higher, and the higher the WACC, the lower the value, right? So what would the valuation estimate have been? What about if WACC has been 6.5%? So if WACC has been 6.5%, then the value would be higher. So we just look for the answers which match our analysis here. The valuation estimate at 7.5% would be lower than the estimate calculated in part A because the discount rate increased. That's correct. In contrast, the valuation estimate at 7.5% would be higher than our estimate, and that's also correct. So we just check. And it turns out all the answers are correct.